So concept 0 with standing waves is to understand that a full wavelength looks like this. So it actually looks like 2 footballs, as it were. Okay, it looks like 2 of these things, and that's because, of course, it's a crest and a trough, right? But these things just oscillate back and forth, so it's hard to see that that's a full wavelength. The smallest unit of currency in these standing waves, the smallest thing we'll divide it into, is a quarter wavelength. So concept 1 is that a quarter wavelength looks like this, or it looks like this. Looks like a water goblet or something like that. Okay? So the first thing you got to be able to do calculations, and these are really simple calculations. If you can draw the picture, you can do the calculations. Okay? The first thing is to be able to count the quarter wavelengths. So let's just look at some of these things, right? Your first example looks like that, right? So how many quarter wavelengths? See if you can figure it out. What do you think? Pause it. I don't know. Think about it, right? Well, I tell you what. Here it is, right? That's a quarter wavelength. Here's the other one. There's 2 quarter wavelengths, right? So the length of this is equal to 2 quarter wavelengths. This is, by the way, called a number sentence. We got a fraction in there, right? So this is the length. And that would be this distance here, right? Let's look at another one here. So look at it, pause it right now, if you need to pause it. See if you can count the quarter wavelengths. All right, so let's take a look at this, right? I can go like this. Remember, a quarter wavelength looks like a water goblet, right? Oops, I didn't miss that one, right? So here's 1, here's 2, here's 3, here's 4, right? So that's 1, 2, 3, 4 quarter wavelengths, right? So we would set up a number sentence. L is 4 quarter wavelengths, yeah? All right, I think we're getting this. All right, let's look at the next one. Think about it. Count how many quarters. Divide it up. Pause it if you need to. Pause the video. You're not pausing. You need to pause. All right, you ready for it? This is a water goblet right here. Right? Here's another one. Like that. So this is 1, 2, 3. That's 3 quarter wavelengths. So we would say L is 3 quarter wavelengths, right? So again, L is going to be this distance here, right? That's L, right? The L is only 3/4 of the wavelength, so presumably the wave is actually a little bigger than whatever the length of this is. Okay? All right. Ready for the next one? Count them. You got to count them up. What is it? Count them up. Pause it. Pause it. All right, here we go. I'm just going to dive right in here. Here's 1 quarter there. Here's another one there. Here's another one there. Isn't it amazing how straight a line I can draw? All right, here we go. I'm not using the shift key to constrain it, right? Okay, so how many quarters we got? We got 1, 2, 3, 4, 5, 6 quarters, right? So I would say that the length of this is 6 quarter wavelengths. So it's actually longer than a wavelength, right? Because remember, this is a wavelength just from here to here. 2 footballs is a wavelength. All right. Hopefully, you know, that's the preliminary skill that we need to have, right? All right. So let's go full tilt here. Okay, this is so cool that I'm going to choose my blue pen. Okay. So this waveform, and when I say waveform, okay, waveform is the length of the standing wave. So waveform is also, we could say standing wave. If this wave is on a guitar string, it's the length of the guitar string. If it's a standing wave in a trumpet, it's the length of all that tubing in the trumpet that's selected by the valve configuration that you're pressing at that moment. Okay? So when we say waveform, it's the length of the standing wave. So when we say 8.45, this is 8.45, like this distance here. Okay? And when we say wavelength, right, the wavelength, that's the thing that's in this formula right here. It's the lambda. If you had 2 footballs of it, how long would it be? That's what the wavelength is. Okay? It's the standard wavelength as in this, right? So the first thing I'm going to do here is I'm going to set up my number sentence here. I'm going to count the quarter wavelengths here. And if you said there were 3 quarter wavelengths, you were right. There are 3 quarters, right? So the length is n lambda over 40. This is in your, by the way, your little formula sheet. So I'm going to say 8.45 is equal to 1, 2, 3/4 wavelengths. Right, so let's solve for the wavelength. The wavelength equals, what is it? Here we go. So what I'm going to do, by the way, is I'm going to go 8.45 times 4 divided by 3. I'm going to cross multiply that thing. And I get that a lambda is 11.2, and there's a lot of sixes. 6 meters, right? All right, we got it. Okay. So that's the first step, is you set up this thing, right? Then there's going to be some question, right, about that you have to use this, right? And we know the wavelength here, so we're going to go V is F lambda. And they're saying that the frequency is 30.4 hertz, so we'll put that in there. Right, and then our wavelength is 11.26 meters. 6. Have I shown you guys how to type in a repeating decimal? I can't remember if I've done that for you. There's a really cool way to type in a repeating decimal. Have me show you in class if I haven't shown you. All right, so here we go. So times 30.4. I'm just going to, it's on my calculator, so I just did that. And I get 342.50666 meters per second. Okay. So those are the steps. Okay. Sometimes you do this first. You find something like the wavelength, and then you do this. Sometimes you do this first, and you do this, right? So if you can't do this, do this. If you can't do this, do this. Okay? You'll do one, then the other.